Hello, Alexey. How you doing?
Hi guys. So I'm happy to join you to join you event, and in a few seconds I think I will share my screen with presentation, and we will go to the deep learning with KotlinDL. This new library developed totally in Kotlin. So give me a few seconds to share screen. Um,
Yeah. So it sounds quite interesting. I'm actually very keen to learn about this as well, to maybe implement some in my job. So yeah, quite quite exciting. I might have some questions at the end.
So I will wait your question. Yes, I don't want to be interrupted during the session, but at the end I will have a time to answer all your questions. And please, guests, attendees, please type your question in the chat. I will answer. So, did you see my screen, Ricardo?
Yeah. It's all there. It's
So
all good for you. So I'll leave you here for
great.
yeah. Cool.
Cool. Let's go. I think that many of you know the Keras library, which runs on the top of TensorFlow, and know what is TensorFlow, heard something about PyTorch, and etc. TensorFlow itself has a stable API, C API, and therefore there are several high-level deep learning frameworks in other languages inspired by Keras, such as TensorFlow.js. Maybe somebody used this in the browser. Maybe Keras.net project. Maybe somebody heard this. TensorFlow in Go, it's used to in Go ecosystem. And today I want to introduce you to a Keras-like machine learning framework written in Kotlin. Currently, the KotlinDL framework can boast that this is the only way to construct and train complex neural networks on JVM, such as VGG, ResNet, and MobileNet. There is also support for transfer learning for the popular models trained in Keras, or maybe available on the Keras.applications page. There are a lot of different models there, including exception, efficient net, and so on. And we started a few weeks ago the implementation of different models for computer vision from this page. For image preprocessing, several functions are available that allow you to avoid complex and routine work on the JVM. For example, maybe you don't know, but JVM has no one stable, good preprocessing library for images. There are a lot of them, different, maybe unfinished, and we provided yet one based on the low-level graphics 2D objects, manipulations, like maybe famous library image scalar, but now it's abandoned and we couldn't use it in the modern preprocessing. And was the reason why we integrated a very minor model in our library for image preprocessing, because doing it manually, it's too hard and painful. So finally, I'll show you how you can build, train, and use convolutional neural networks like CNN, maybe very different in architectures entirely in Kotlin, with the help of our framework. And maybe we will touch in some points how to use KotlinDL models in production now. So let me introduce myself. I'm a Java and Kotlin developer for last 2 years. So I'm started in this work like a distributed ML enthusiast. Started my work from writing special distributed ML model for the Apache Ignite in-memory database open source product. So after that, I became a TensorFlow contributor. I started my contribution to Java API of TensorFlow, for core TensorFlow, and so on. After that, I joined to JetBrains as an ML engineer, but not as a researcher, but like a framework writer. Also, you could follow me on the GitHub, on the Twitter. You could follow different projects related to my JetBrains activity, or maybe to my Apache activity, all of them related to the ML frameworks, different ML frameworks. So I want to say a few words about motivation, why we started in JetBrains develop different tools for machine learning, for data science, etc. in last 2 years, Kotlin took a course to become a convenient language for data science. We started from the Let's Plot framework for visualization. After that, we wrapped Python library NumPy. But it was a temporary solution. I mean that at this time we decided to remove the Python layer, which gives us a lot of overhead, and now we are trying to invent new library for multidimensional arrays in Kotlin. I will talk about it later, some words. So no modern data science today without neural networks. I think you agree with me. All deep learning frameworks are good enough at image recognition, and this was the reason why we started from this domain, not from audio preprocessing or maybe from famous GANs. So we started from the convolutional neural networks because a lot of tutorials how to start from this, and it could be a first step for newcomers, for newbies who started in Kotlin, learning maybe deep learning, maybe switches with stable model from Keras to continue his experience with stable models provided by Keras. So training, transfer learning, and inference are now available for different CNN architectures on Kotlin with KotlinDL library, and today I will provide some information about it. So KotlinDL is a Keras. You could see on that today like an Keras framework, but written in Kotlin. So Keras, in reality, what is that? This is a TensorFlow C++ runtime plus low-level Tensor API plus Python high-level framework with layers and models. But for example, a few years ago, it was very teeny layer of Python code which wraps the low-level C++ runtime. I mean TensorFlow 1, where there will be a lot of different low-level operators, but then Keras project with friends actually joined to the Google, and it was merged to the main code repository. Now we in many cases thinks about TensorFlow like about low-level relatively Keras API. So we remove the Python code. Imagine we remove a Python code from here and rewrite a part of that in KotlinDL. Not exactly the same, not every string. This is not the goal of our framework, but the high-level API is the same, and some internals calculation is too close to the Keras and give the same results in many cases. So perhaps wrapping Python is difficult and painful, and we reject this way. We have such ability in Java or in Kotlin to wrap the Keras framework, but we had a painful experience with wrapping of NumPy, and we decided to start it from zero to here. So from the very beginning, there was a low-level Java API in the TensorFlow main repository for inference, and it was marketing like an API for inference only. But 2 years ago, I found very strange undocumented classes which was in the repository and which gave us ability to train simple models, and not only simple models but very complex models on the Java API, a low-level Java API. It was undocumented. It was not published on the TensorFlow site. It was very strange, but it was the entry point for our research and for our library now. So how it works? Somewhere in the depths of TensorFlow, there's a C API, as I said, and it's suitable for generating bindings on the top of it for other programming languages, including Java. Java, Kotlin has a full interoperability with Java, and we could use all these classes which could be generated. Also, Java has a special technology which could help to call C functions on the Java side. It means it's famous like a GNI technology, and we can generate so-called native methods in Java. So in our case, these methods were generated located in the main TensorFlow repository, and it reduced our work on wrapping. So after that, you can already build a Java API of varying degrees of complexity, and sometimes this is done by hand. For example, I saw a lot of projects where guys trying programming method by method, but there are a lot of, I don't know, a few hundreds of low-level operands and TensorFlow API, and it's very difficult to wrap all of them in the same manner. So in the case of Java API TensorFlow, hundreds of classes for all sorts of operators were generated by a special C++ class. Now in the new version of Java API, it's rewritten with Java, but it was this C++ which generates 4,000 classes in Java in the same manner. So in any case, this low-level API also comes with TensorFlow and is developed in close cooperation with Google, and it's enough stable. So, and at the top of this level is the Kotlin code level, which provides the top-level building blocks for creating and training neural networks, such as activation functions, weight initializer, layers, optimizers, loss functions, and so on. And TensorFlow operators are used to implement these building blocks. But in the future, for KotlinDL, it's planned to switch maybe on the PyTorch operators when we will wrap the special part of our PyTorch C++ front end with these operators, or for example, with some of our with some guys from other teams, we are going to write some custom kernels implemented using our multidimensional array library, Multic, or maybe the NVIDIA libraries like CUDA, JCUDA, and so on. Maybe it will be our own kernels. We don't know. We have a lot of experiments here, and the performance, the final performance for us is not very critical at this moment. But I think that in the future it can be changed. So the possible future could be this, like on this slide. I'm sorry, I'm not a designer. I create this picture from the different rectangles, but the architecture in future could be like on this slide. We could have the same Keras-like API and bind with different runtimes via GNI and Java, with Onenix, with PyTorch, with TensorFlow, or maybe with alternative libraries if they will have a C++ or C API. Maybe JAX from Google, from DeepMind will have this kind of API in future, and we will wrap it too. Why not? So I want to say a few words about our ecosystem for Kotlin for data science, because I want to invite you in our ecosystem. Don't forget about Python, but try to taste some interesting things in Kotlin. So first of all, we released our multidimensional array library for Kotlin. It has Kotlin pure implementation and native implementation with OpenBLAS under the hood, and it could achieve the comparable performance with NumPy, the multi-native implementation, I mean. But for example, the JVM implementation on the pure Kotlin could be executed on Android. We are going to release support for Android for multidimensional arrays during this year. I think it will be available for different interesting things on the Android side, and maybe in the future release, it became maybe you know the multi-platform library. It will be available, for example, on iOS, on the Android side, on the JavaScript, the same API, the special technology for Kotlin. You write on Kotlin, and it's available and compatible with different languages. So, but it's very experimental technology, and I think it's too early to say how it will be in the next year, for example. Also, we have bindings for the Apache Spark project for distributed training. So it provides Kotlin idiomatic API, type and dimensional safe for different Spark operations. So also, this project adds a missing layer of compatibility between Kotlin and Apache Spark. Apache Spark has Python, Scala, Java, R API, but the Kotlin wrappers for Scala looks ugly in my opinion, in my humble opinion, sorry. And it was the reason why in the team, the Pavel Filkic team wrote a wrapper and the idiomatic Kotlin. So also we had a data frame library in progress. It's not the copy of Pandas library. It has special, of course, Kotlin idiomatic API. You could do the same like in Pandas, maybe more Kotlin idiomatic way. So and also it includes a few new operations which could be used by users in different use cases. I think it will be released soon in next month possibly. So also at the end, last but not least, let's plot library for visualization. It's multi-platform and can be used not only with JVM, also supports JavaScript usage and Python usage. For example, you could take this library to the Python ecosystem and use with different Python libraries on this side. So also. It's wonderful, but it works together in Jupyter Notebook, and not Jupyter Notebook, if you know, supports different kernels for different languages, and now it's very, very interesting to mix them together, not only in IntelliJ IDE, but it supports the Kotlin kernel too, which is open source project that brings Kotlin support to Jupyter Notebook, and it has a lot of pluses for using with strong typing languages with different auto completions and etc. and so on. Please try Kotlin DL with Jupyter Kotlin kernel with Jupyter Notebook. It's a very interesting experience. So why was Keras taken as a sample, which is more and more often overshadowed by its competitor PyTorch? I will answer you. So the fact is that they developed in different ways and under the influence of different ideologies and interest groups, in my opinion. So while researching our potential audience in the Kotlin community, we came to the conclusion that we are closer to the ideology of working with neural networks offered by the Keras framework. What does it consist in? So the Keras API philosophy, from the last words of the Francois Chollet, creator of Keras, progressive disclosure of complexity. Progressive disclosure, from the Wikipedia definition, is interaction design pattern often used for making application easier to learn and less error-prone. Imagine macOS UX. It does that by differing some advanced or rarely used features to a secondary screen. You should start from the very limited set of features and go deeper step by step. So I stole this slide from the Francois Chollet presentation. Sorry, Francois. What ordinary users want, those users who are not deeply immersed in the mathematical foundations of deep learning. I thought about that a lot, but who want to use its capabilities on a regular basis, maybe developing the backend and mobile applications. I think it's maybe not ordinary users, but engineers, practitioners, and etc. But what we want, we asked our audience, they wanted best practices baked in by default. For example, best initial values, best activation functions, and so on. Don't think about that. Don't use the hyperparameter tuning. They want as little code as possible. They want easy logging. They want clear explanation exception. For example, from my experience, then I started my work with TensorFlow low-level exceptions. It was very, very, very strange text in all of them. You really couldn't understand what's happened. There's something with shape, something with tensor, something strange with C++ API, and we are trying to replace this strange exception parse part of them to create very clear explanation. What's happened? Then you compile your model. What's happened? Then you're trying to fit. Maybe make some tips for the users. What should be improved in his model to get better results, and etc. I think a few tips could be taken from the Andrew Karpathy tips how to train neural networks, and it could be very useful for starters, for newbies in deep learning. Also, KotlinDL contains a lot of examples, I think, for all use cases, which is possible with this library. And you could easily copy paste to your project and start. So users with advanced engineering skills whose destiny is to roll models into hot productions like hot potatoes, prepares an infrastructure for experiments, and quickly tune ready-made models to suit their needs. What do they need? I thought a lot about that too, and we explored our audience here and asked a lot of questions. And engineers answered that they wanted flexible model architecture, a lot of building blocks which could be easily joined together, flexible training logics which should be hidden from the practitioner, transfer learning, of course, because they don't want to train the models from zero to hero from scratch, yeah, but take the ready model and maybe retrain the last layer, the last dense layer with a few neurons to fine-tune the model loaded, from example, from the Keras applications. They wanted transfer learning, of course, and different export and import for ML ops needs to different systems like ML ops, for example, I'm sorry, as ML flow, for example. But what about researchers who are giving birth to the new models? We have a double trouble with researchers. They don't want a framework in our research for researchers. They don't want a framework. We want just a toolbox with low-level control of every detail. They want a custom gradient loop and be able to add new components on the fly. And on the start of development of our framework, we need to decide for what audience is the main for us. And we decided that we will work, first of all, with basic users and with practitioner engineers, but not with the researchers, because we are using runtimes from PyTorch, for example, from TensorFlow, and we need a time to adapt new technologies, new neural network architecture, and so on. And what opportunities does KotlinDL give now? I would say that it's more focused on the basic users, as I said, and in the next releases, we will make KotlinDL more open, I think. It will be possible to add your own custom components, such as an activation functions. It's very small component, loss functions maybe, layers, optimizers, and initializers. But I'm not sure that we will delegate the full control on the training cycle, like in PyTorch or different new modern frameworks for researchers. But for now, you can send us a pull request, for example, and new developments will be included in the next release. I promise you every layer, every new initializer, and maybe every new optimizer. But it is hard to add new optimizer now because we are limited by the TensorFlow runtime. So as I said, if we look at the model training from simple to arbitrary flexible, at the current moment, KotlinDL provides the model fit method for quick experiments and provide callbacks. I know that, for example, in PyTorch Lighting or in Catalyst framework, it's now the time for adding the callbacks, because PyTorch has very strange experience. Basic PyTorch has very strange experience with callbacks. I don't remember exactly. Maybe it's not included in PyTorch now. I mean basic PyTorch, but it's available on the high-level frameworks, which was inspired by Keras, maybe. I'm not sure about PyTorch Lighting. So also, if you are a researcher and you want to be experienced researcher written in Java or in Kotlin, if you need a low-level manipulation JVM, you could use a Java API for 1.x or 2.x TensorFlow runtimes. But I have one note for you. Java API for 1.15 is stable and fast, and we are based on this runtime. It doesn't influence on interoperability with modern Keras. We could load model from modern Keras from model TensorFlow, but we are using previous runtime because it's faster in many cases. But Java API for 2.x is under development and has a few performance issues related to the garbage collection, but it's ready for experiments, and I think all models will work, but maybe you will take a few memory leaks. Don't use it in production yet. There are a few useful links here on the slide, and you could find here a few of my articles about how to write, for example, LeNet 5 on the low-level operands. It's close to your experience how to write the same on the Python, but the naming is bigger with this. So let's talk about KotlinDL features. I told a lot about ideology, about ecosystem, but let's go to the features. It's very, very, very short list. So the previous release, alpha release, supported sequential API. It's very, very simple API. You stack layers in one line. So, and you can build only VGG-like sequential models like VGG 16, like VGG 19. So it could be exported from Keras. You could download these models, with their weights, and make transfer learning on your side, for example. Also, previous release supported training on TensorFlow, for example, for classification and regression simple models and for VGG-like models too. But no interesting residual connections and etc. and etc. But the upcoming release will bring to us. I said upcoming because the alpha version is available on Maven Central today, but I think that the stable version for it will be available in next 2 weeks. So the upcoming release will bring to us at once several significant groups of features on board, and I'll start with the first and most important one. The so-called zoo of models is available, which includes a special loader of configs and model weights for each of which the original data preprocessing is available. Applied during training on the ImageNet dataset, it's very different. For example, MobileNet trained with one type of preprocessing, ImageNet, I'm sorry, ResNet version 1 with alternative type of preprocessing. All of them are available in Keras applications model, and we moved the same. We wrote the same preprocessing on the Kotlin side too, because it's very important to preprocess new data for transfer learning, for example, in the same manner. So the next new things, the addition of new layers, which are required for building ResNet architecture, MobileNet architecture. It's batch norm, activation layer, deep-files and separable convolutions, different merge layer to merge your different branches in the model, all 7 of them which are available in Keras. It's global average pooling, the new replacement for the last dense layers, cropping 2D, reshape, and zero padding 2D. It's not exactly all the layers which will be available in the final version of 0.2 release, but I think the most of them. So also it includes embedded data sets which are located on our servers, but it could be downloadable via different simple functions like MNIST, Fashion MNIST, Cephar 10, and famous, maybe somebody remember, dogs versus cats image data set from Kaggle. I started from this data set a few years ago. My way in deep learning, I think it's very interesting to retrain your last layers in your model with a few images from this data set. For example, if the pre-trained model was trained on the ImageNet, I think that cat and dogs are compatible with the ImageNet images. So also, the next group of features is, as I said, the image preprocessing. We have a special Kotlin DSL for image preprocessing with supporting of crop, resize, rotate, load from the directory and saving to directory operators, also rescale. It's very important operation too. And for example, the basic augmentation, we have no augmentation library in support yet, but the basic augmentation could be realized easily with our DSL manually, for example, for your needs, if you need augmentation for training on the real huge data sets. Also, we have different data sets. The reason that traditional way to run data through the neural network in forward mode is to load batches one by one into RAM and then into the memory area controlled by, for example, by the TensorFlow computational graph. We support this approach with on-the-fly data set. He sequentially, during one training epoch, loads batch after batch into RAM, applying the preprocessing described in advance if it was defined. For example, you could miss this step. But if our data fit into RAM, for example, we have 100 gigabytes of RAM or 1 terabyte, let them load and keep all this data in RAM. Why not? Without reading it over and over from disk at each epoch, it's like a caching into your RAM memory. For example, on-heap dataset is your choice for this use case. So, of course, like all new frameworks, it has a few limitations. Now it's useful for image recognition task and regression ML only. For example, you couldn't train task from speech recognition domain, for example, or maybe new cool modern style GANs. But I think it's in future it will be available too. It has limited number of layers, and at this moment it has no Android support. Sorry if you joined this meeting thinking that this is a Kotlin for Android and you think it about this to this moment. It's Kotlin for backends. By our polls, 1/3 of users used Kotlin for backends, but I think that at the end of this year, we will provide a few wrappers for working and maybe training for TF-Lite format. You know, this is special, highly optimized format for TensorFlow, and not only TensorFlow models on the mobile devices, and maybe if PyTorch will improve his own mobile formats, we will wrap it too in the after working with TF-Lite. So KotlinDL roadmap, I highlighted a few moments from this, but especially I need to say that in the following releases, we will add new models to the model zoo. Inception, very famous model; DenseNet, not so famous; EfficientNet, and maybe if the Keras framework will provide in applications EfficientNet version 2, or maybe new NF nets without batch normalization. We will add this model in our model zoo 2. Also, I'm going to add a special tunable GPU settings, because now it's very hard to tune the fraction of occupied GPU memory, for example, in KotlinDL. Also, a few missed things in our framework. It's a regularization for all layers. Sometimes it's very interesting techniques which could improve your experience with neural networks. New metrics will be added. Also, as I said, conversion to TF-Lite format in Kotlin, not in Python like now. Also, we are going to integrate on NX and PyTorch runtimes also. Maybe if you're interested in it, if you know, for example, Kotlin, very good, or Java, we will have a separate project, a separate model in our project to create different ML, classical ML algorithms like decision trees, linear regression, etc. in Kotlin, and you could join us to add more new algorithms when basic interfaces will provide it after a few months experiments. So is it time for demo? I have not so many time, but I want to share my IDE to run a few simple models because I want to demonstrate you how it could be written in Kotlin. So give me a second to share my IDE. So I hope you see my screen. Just a second to check. Yeah, I see that you see my screen. So here we in the simple project which named KotlinDL demo. It's available on GitHub too. I will share links in the presentation for the organizers, and they will share review. So here we see the simple iris dataset. Maybe do you remember 3 classes, simple classification task, 4 features. for features for every of that, and we could build very simple neural network input a layer with 4 neurons because we have 4 features, huge dense layers with 200 neurons, activation function, kernel initializer, bias initializer, and the final dense layer with 3 neurons because we have 3 classes. This is the model description in Kotlin. So here we need to shuffle our data prepared in just an array, so and create the on-heap dataset because it's very small tiny data. So we need to split data set to validate on the tests subset, and we could go deeper with our model. All these steps may be familiar to you if you have experience with Keras. You need to compile the model, to compile the underlying TensorFlow graph. You need to set up the optimizer, loss function, and metric. I will prefer accuracy metric for classification tasks. After that, we could print the summary of our model or layers. I will run model to check this, and we could start the training. We are calling the feed method, where we could pass the link on the train data set, the number of epochs, the size of batch, and we could evaluate our model on the test subset and calculate accuracy. The final accuracy is enough high, but if we will revisit our model, we will see a lot of neurons. I think it was learn all training examples here, but don't worry about that. This is a logging. I use standard Java logging for this model. This is, for example, log4j logging, described with XML file. You remember this technology? This is that. So this is simple console output. It could be outputted to the file, for example, to the database if you want, and etc. We have 3 simple layers. We have number of parameters. So different stats about batches, about our epochs. It prints the stats not like the Keras. You remember this special line we change from second to the second, but we work on it. So the next example is the training the simple LeNet. The difference is in the model description here. So if we will go to the training model, it's the same. We compile the model with alternative optimizer, where we clip in gradients by the value. There's the same loss, there's the same metrics, and the same code of training. I think that we could imagine the easy method. Then after definition of model, we could call only one method, train, with default settings. So the model definition is the following. We define the input. To define the input shape of our data on MNIST dataset. For MNIST dataset, we call the special function MNIST, which loads the MNIST dataset for us and put is in the special cache folder on our disk and the special subsets. You could replace this path to your custom path if you need, but by default it will be downloaded to the cache dataset NIST, and all the famous images in the ubyte format will be loaded here, will be located here. So also the LeNet has convolutional layers, max pooling layers, again convolutional, max pooling, flattened layers, and dense. No new things. I think should be very familiar. Maybe, I don't know, the formatting of code is different. Maybe from the Python experience and from your Java experience. But the difference is the strong types. For example, you could go to all these variables have types, and all are building block have types, and it's very easy to program. Also, as you know, the IntelliJ IDEA has auto completion. It's very easy to code these models, these model definitions. So also we will go to the production ready example with ResNet 50 model. It could be loaded from the model zoo. located in the same directory, cache/pretrained models. You could choose the model type, which should be downloaded. For example, you could download it VGG 16 or MobileNet version 2 if you want, but we will stay with ResNet 50. It loads the configuration of the model, the definition of the model in JSON format. For example, you could find it here. This is model JSON config. This is a totally Keras description of the model, and we support this format because in future we want to be able to train our models, for example, in KotlinDL, load them to Keras if you want. So also the weights in H5 format are loaded too, and you could compile your model with anyway losses because it doesn't influence our prediction, and preprocess the data with special preprocessing DSL, preprocessing pipeline. We need to define loading from the resources directory. Here a few photos. For example, this is me, but younger in 2 years, and a few images: pigeon, cat, broccoli, no, tree, I don't know, car, strange fish, which reminds me nipple, sorry, brown beer, and really goldfish, like on the 6th page. Let's see what will be predicted by ResNet 50. The top 5 labels will be printed. So this is a lot of loading H5 sets. It's debug messages. It could be disabled, of course, by our settings, but let's check. On the first image with young me, it was found jersey, lab coat, tube, hand blower, sunglasses. Okay, but not the real man. Okay, so Petrich, Veteros. Okay, it's close to the pigeon. I'm not sure about the real type of this animal. Egyptian cat, exactly the same. It's Egyptian cat, sports car, broccoli, not real tree. Agree, this tree reminds me broccoli too. Goldfish was found on the 6th image, and brown beer and goldfish on the last image with different degree of accuracy, but was found too. So, but if you want to really transfer learning, not only for prediction, but if you want to retrain something, you could try to get the initial model, for example, to load it from the model zoo, describe the preprocessing. For example, I want in this sample, I want to retrain the last layer on the cat docs small data set. Only 1,000 images per class in this data set is subset of the whole cat docs images data set. And I want to resize all these images because they have very different sizes to the input of our neural network of ResNet 50, and after that I want to remove last layers. This is a code to remove last layers. We need to remove layer and remove all boundary lines with previous layers here, and we could add in functional API manner new 2 dense layers. For example, we've named top dense and prediction, and create the functional model from the last layer. It's close to the Keras functional API, but we don't need an input here because it will be found automatically. So we will compile the new model with optimizer, losses, metrics, like in the previous examples, and we could load weights only for the frozen layers of the previous layers. For example, all of them were frozen by default, and only 2 last dense layers will be retrained from the random initialization. And please look at the screen, just a few seconds. And we will check, we will evaluate new model before. We will evaluate it before training, accuracy before training only 42%, but after our training, it will achieve more high accuracy. Just a few seconds. Oh, okay,
Hey,
it will
Alexey.
achieve.
Yeah.
Oh, sorry, yeah, the time
Yeah.
is
So we're
finished.
running a little bit of time. Yeah. So, but it's quite good. Yeah. It was quite exciting. I think it was 90% accurate, 98. Nice. Nice.
Okay. We'll show only last slide if you give me a second. Only last slide with links. But
Yeah.
as
Yeah.
I understand, we have no time to answer the question, or we will have time.
No, I think we are running out of time, but you still can post questions in the comments and you can respond right there in the YouTube comments.
Okay, just a second to share screen. Yeah, I will take more time than decided before. Sorry for that, guys.
It's fine, no worries.
Yeah, just a few useful links. I want to say a few last words. Please follow us on the GitHub, start this project, support us. If you want, you could search all of our Kotlin data science ecosystem. You could join our Kotlin Slack to the deep learning or KotlinDL channels. There are a lot of different mathematics channels there. Join all of them. Join our discussion on GitHub and follow me. I will post new news about that on Kotlin for Data or on Zalislav Twitter. Okay, thank you for your attention, and we'll wait attention layers in KotlinDL.
Awesome. Thank you, Alexey. Thank you. It was quite good.
Okay, I will answer in chat. You guys, thank you for your question. We'll go to the chat.